Hello, good morning everyone. So, good morning to all the participants who have joined us in this room and all the participants who have joined us online. Welcome to our session on technical solutions for secure water supplies. So today's session we'll be exploring how embracing circular economy can transform our water systems and ensuring that every resource is maximized and reused, paving a way for a much more sustainable future. So, if you see on screen, today's session is a three-part series in the SIWI Technical Solutions for Water Supplies. We have already had the online session wherein we discussed the introduction to technical solutions. This is the second series where we'll be focusing more on the circular economy section. And we have a third session which will be taking place tomorrow. And over there we will be discussing the Wi-Fi nexus on transboundary contacts. And that will happen tomorrow at between 11 and 12:30. So today's session we'll be focusing mainly on circular economy and the innovative solutions that are there in the field. I would like to welcome our moderator, Dr. Rebecca Peters, who will be moderating this whole session. So Dr. Rebecca is a senior international water policy advisor for the US State Department. And previously, Dr. Peters was also an Aspen Institute Climate Fellow and a researcher at the World Bank Inspection Panelist. She also served as a Liu Scholar at the International River Center in Kunming, China. Over the course of her career, Dr. Peters has worked closely with community groups, government, industry, and river basin organizations in more than 25 countries. So I welcome Dr. Peters to come on stage.
Thank you. Good morning. Thank you, Stephanie, for the kind introduction, and thank you all so much for joining us here this beautiful morning in Stockholm. I cannot be more pleased to be joining this wonderful group and to be introducing our esteemed panelists in this really timely discussion this morning. We're all here in Stockholm because we know that addressing water challenges is arguably the most pressing issue of our time, but the way water intersects with economic growth, development, opportunity, all of these are the issues of our time. And we're here today to make some progress toward understanding what are our opportunities, what are our options, what are our challenges, and how can we rise to meet those challenges today. And so up first to speak with us about what we can do is Berenice. If we may advance the slide, please. Oh, am I doing that? Oh, here we are. Berenice is the Process Research and Operations Manager at Wingnok and the new Goreab Reclamation Plant for direct potable reuse, where she draws on her 10 years of experience as a chemical and process professional. I'm really pleased to welcome to the stage Berenice. Please, over to you.
Good morning, everyone. Thank you so much, Rebecca, for that welcome. Yes, so today I would like to share with you and speak to you about Wingduk and the case study there, where we have implemented a robust and resilient water management strategy in order to secure our water resources. So just to give you a brief background on Namibia. Namibia is an arid and semi-arid country with two perennial rivers, which are at the extreme north and south of the country. Windhoek itself is situated on the Central Highlands, which is a very long distance from these two rivers. So essentially, Windhoek's only source of water in the 1960s was basically groundwater. So during the 1960s, because we had over-abstracted our groundwater resources, we found ourselves in a very insecure water situation where we needed to find alternative sources of water. So during this time, in the 1960s, Windhoek decided to research and as well as implement, using the available technologies, DPR, which is one of the 3 pillars of our water management strategy. So DPR is direct potable reuse, where we treat wastewater to drinking water quality. The first plant was constructed and implemented in 1968 and to scale. So this is still currently the biggest DPR plant in the world, and it was pioneered first in Windhoek. The second plant, which is known as New Goryanga Reclamation Plant, was then built in 2002 and commissioned in that year, where we have a capacity of 21 megaliters per day. Yes. So ideally, the process there that we incorporate is ultrafiltration, activated carbon, as well as ozonation as our premier disinfection process. It supplies about 30 to 33% of the city of Windhoek's daily water demand. Yes, so we provide about drinking water to about 500,000 people in the city of Windhoek. So that is the one key pillar in order to diversify and augment our water supply. Second to this is the industrial water reuse facility known as UYAMS. UYAMS was built by the city of Windhoek in order to protect the wastewater treatment facility. Because domestic wastewater treatment is one of the key barriers for the DPR process, we needed to ensure that the water going to the wastewater treatment plant was only from a domestic source. So in order to do this, we decided to divert industrial wastewater to a designated wastewater treatment facility in order to protect our barrier for DPR and to ensure DPR safety. So then it was decided in 2011 to build an industrial wastewater treatment plant, which is fed by food and beverage, tanneries, textile, and an abattoir. So that water is not diverted to our domestic wastewater treatment facility, but rather to the industrial wastewater treatment facility. It was also done by the city of Windhoek, where we changed our policy to force these industries to do pre-treatment before diverting their wastewater to the environment, where they do on-site pre-treatment, and then the water is transferred to the industrial wastewater treatment facility. This provides an additional fresh water demand for about 60,000 households in the city of Windhoek, and also ensures that we protect our environment from illicit wastewater discharges from industrial users. And then finally, we have the third pillar, which is complementary to our DPR process. So ideally, what we saw, City of Windhoek gets water from 3 sources: surface water, DPR, which is direct potable reuse, as well as the aquifer. But during times of drought, we extensively utilize our groundwater resources. And we found that when we have rainfall, it would be ideal to bank this water for times of drought, which are very frequent in Namibia, as we have a very arid climate. So it was decided by the city of Windhoek to artificially recharge the boreholes, the groundwater aquifer that supplies the city of Windhoek during times of rainfall. This was done for water security and to ensure that we have future water supplies in our resilience city program. And then ideally, because we want to maintain a high quality of water to recharge, they decided to blend the water going into the aquifer with about 30% of the water coming from the DPR source, and then the 60% balance coming from surface water sources. Yes, and then this supplies about 10% of the water demand during drought periods. Yes, so just to summarize, Those are the three pillars that the City of Windhoek has incorporated in their water management strategy in order to build sustainable and resilient water sources for future generations. And I think that this is one of the greater models that other arid regions can actually use in order to facilitate their development towards a sustainable and resilient future. Thank you so much.
Thank you, Berenice, for starting us off with such a strong case study and example of what can be possible when we can apply technology, but not just technology, really thinking critically, creatively about ways to be more efficient, more effective, protecting both people, communities, infrastructure. I'm now very pleased to bring to the stage someone else who can speak quite extensively to dealing with water in an arid climate. Heather Cooley is Director of Research at the Pacific Institute, which is a nonprofit think tank that provides independent policy analysis on issues of development, environment, and security with a focus on fresh water. At the Pacific Institute, Heather oversees and coordinates programmatic work on water efficiency and reuse, as well as nature-based solutions, water equity, and corporate water stewardship. As a fellow Californian, I could not be more grateful to the work of the Pacific Institute in advancing our work on water efficiency and reuse in a similarly arid climate. So Heather, over to you. Thank you.
Okay, well, thank you, Rebecca. I'd like to also thank SIWI and the session organizers for inviting me here today, and for all of you in the room and online for attending this session. I'm Heather Cooley, Director of Research at Pacific Institute. Pacific Institute is a global water think tank that creates and advances solutions to the world's most pressing water challenges. And today I'll talk about a new Pacific Institute study that quantifies the untapped potential for water efficiency and reuse in the United States. And while focused on the US, the methods and approaches and some of the key conclusions are relevant for communities around the world. Across urban areas in the US, water is typically used just once, treated and then disposed of, whether it be through land or into waterways. Similarly, our urban areas were designed such that stormwater is collected and removed as quickly as possible to minimize flood risk. And in many areas, we see that water is wasted through inefficient, outdated appliances and fixtures and irrigation systems. We see leaky pipes that are leading to water losses. And we see irrigation of very water-intensive landscapes that aren't well suited to the climate there. And as traditional water supplies have become constrained, we are seeing both greater interest and investment in turning that wasted water into a valuable resource and transitioning towards a circular economy for water. And we are seeing evidence of considerable progress in this transition. This figure shows indices for U.S. gross domestic product for population and water withdrawals from 1900 through 2015. That represents the most recent year for which water use data are available. And as shown in that figure, for much of the 20th century, water use increased as population and the economy grew. But in the mid-1960s, we see that the rate of increase in water use began to slow, such that water use peaked in 1980 and has been declining since. This decoupling of water use and growth really flies into the face of many of the assumptions that we have, and it's also due to a number of factors. It's due to efficiency improvements, it's due to some on-site reuse, changes in our economy, denser development. There are many things underlying that transition. But a key question is how much more is possible? How much can we reduce water demand through existing technologies and practices? how much wastewater or stormwater is available to further augment and diversify our water supplies. So to answer these questions, the Pacific Institute launched a major initiative to quantify the national potential for water efficiency and reuse. And I'm delighted to be here today to present some of the results of our first study that looked at urban stormwater runoff. So let me first start by defining urban stormwater runoff. Urban stormwater runoff is generated when precipitation falls on rooftops, on roads, and other hard surfaces. As that water flows over the urban area, it's picking up pollutants, things like metals, pesticides, oils, and it then carries those into our nearby waterways. Stormwater can also flood low-lying areas, and as a result, stormwater has traditionally been viewed as a nuisance. And as I mentioned, our urban areas were really designed to move it out as quickly as possible. But perspectives on stormwater are beginning to shift, and increasingly it's being viewed and seen as a valuable asset. To understand, and that then kind of led to, I think, our interest in understanding what's this potential. So to understand the amount of urban stormwater runoff available and generated in the US, we partnered with Second Nature Software, which is a small US-based company, to model stormwater runoff for nearly 2,700 urban areas of a population of at least 5,000 people. So it was a very large analysis across the entire US, both the continental as well as Hawaii and Alaska. And I'm happy again to present some of our key findings. We estimate that the average annual stormwater runoff potential in the United States is nearly 75 cubic kilometers per year. So to put those numbers in perspective, that's equivalent to about 93% of the municipal and industrial water use for the United States. So it's a significant proportion. While I would argue it's not technically feasible or even desirable to catch all of this water, some of that water, in fact, is already meeting downstream water needs for people or for ecosystems. However, what we're seeing are that coastal areas offer an outsized opportunity. These account for just 12% of the urban land area, but 37% of the urban stormwater runoff. These coastal areas are particularly attractive because these areas have fewer sort of downstream users, downstream constraints. And in fact, in many of those areas, capturing that stormwater can also improve water quality in those coastal waterways. So based on our analysis, we conclude that stormwater capture can make a meaningful contribution to augment and diversify water supplies in communities across the US and further help support not only sustainability, but resilience. This study was recognized by the US EPA in its Water Reuse Action Plan. It was also picked up by a number of major media outlets across the US. And so through this attention, this research has really brought forth the idea of urban stormwater capture, the fact that it is an opportunity that should be considered and evaluated as communities deal with limits on traditional surface and groundwater. And this awareness is really critically important to obtaining public support, but also public investment in these types of projects. We see that as a key strategy for helping build resilience. In the coming months, we'll be releasing work looking not only at stormwater runoff, but also urban water efficiency and the potential for reuse of municipal wastewater. So stay tuned for some of those results. So let me quickly summarize. By turning water into a resource, water efficiency and reuse offer significant opportunities for a circular economy of water. We've made significant progress in this area, but new research shows there's still significant potential, untapped potential, to expand water efficiency and reuse, including of urban stormwater runoff across the United States. These findings underscore really the critical role that these strategies can play, not only in meeting SDGs 6.3 and 6.4, but also more broadly reducing pressure on water resources and the risk of conflict. Importantly, understanding the potential is important. As I mentioned, it helps to kind of raise awareness. It helps to encourage folks to look at these opportunities. But it's also critical to adopt effective policies and programs so that we begin to make this unrealized potential a realized potential, and help to solve the critical challenges that we face. If you're interested in reading more about this work, I'd encourage you to download the study from our website. And I'd like to close by thanking some of my amazing colleagues, including who aren't here today, but were critical to this work, including Brooke Bahanu, who led this study, along with my colleagues Shannon Spurlock, Jessica Deary, and Morgan Shimabuku. I'd also like to thank our communications and outreach team, including Sambul Mashadi, who's here today as a junior rapporteur. And I'd like to thank our partner, Second Nature Software, for this work. So with that, thank you.
You'll do that slides. Okay, thank you, thank you. Excellent. Thank you so much, Heather, for bringing some of the United States perspective. Having heard now about Namibia, about the United States, we're going to turn now yet to another geography and another solution set. We've talked quite a bit about physical infrastructure, and now we're going to transition into talking about the digital infrastructure necessary to ensure solutions in this area. And I'm very pleased to introduce our online speaker, Javier, who is a senior researcher at the International Water Management Institute, a nonprofit research organization based in Colombo, Sri Lanka, with offices across Asia and Africa. Javier serves as the coordinator on work for water quality, where he brings extensive experience as an engineer and environmental scientist. Welcome, Javier, and thank you for joining us.
So thank you very much, Rebecca. I guess that I will have now my slides displayed, and then I will start by saying next slide and things like this. Yeah, thank you, excellent. So yes, hello colleagues, hello everybody. I'm gonna be talking about digital solutions for water reuse assessment and planning, which is critical, as it was mentioned before by Heather, that planning and assessment of reuse potentials are essential for prioritization of investments, right? So next slide, please. I will start with some basic concepts about wastewater fate. So we have municipal wastewater that is generated in cities and towns. This wastewater, of course, can be collected in sewers or not collected. It can be treated in treatment plants or not treated. But what is most important, this treated or untreated wastewater can be directly reused for beneficial purposes when it's reused undiluted, right? For agriculture, for direct potable reuse, etc. It can be indirectly reused when this treated or untreated wastewater is discharged to the sea or evaporates with no productive use, when it's discharged in the desert, or when it runs along rivers and evaporates with no productive use. This is the lost wastewater. This is the wastewater that can be recovered and brought back to the water budget as new water. So we have quantified in IMI for the first time ever this direct amount of wastewater that is directly reused, wastewater that is indirectly reused, and the lost wastewater in Middle East and North Africa. So next slide, please. We have put together a model that we call sewage track, that stands for Spatially Explicit Wastewater Generation and Tracking Model. And we have developed this model and run it in Middle East and North Africa with results that are published. And I will share later in the chat the paper that brings all this data together. Basically, the model has two modules, which are these two cylinders that you see in the slide. The left one is the module on wastewater generation, and then we have another module on wastewater fate. So the module on wastewater generation feeds from data like gridded data sets on population, also data on the national wastewater generation from national statistics, and per capita wastewater generation in rural and urban areas in different countries of the region. With this, we are able to produce gridded data sets of wastewater generation. So we know how much wastewater is generated and where it is in the countries. So this is a resource that we can mine. We need to know how much we have and where it is, right? So we now have the wastewater that is generated. Then we also made the largest inventory of water reuse projects that directly reuse the effluents of wastewater treatment plants for beneficial purposes. And then with the total amount of wastewater generated minus the amount that is directly reused, you can get the amount that is either lost or indirectly reused. And with a number of calculations and assumptions, we modeled that in Middle East and North Africa, 54% of the wastewater is actually lost in the sea, lost evaporated on land or along rivers. This is the blue part of the last circle you see on the slide, right? The direct reuse of this wastewater is only around 10%, which is the green area you see on the circle on the right. And then the amount that is indirectly reused is 36%. So the region cannot afford losing 54% of these resources. And it's important to know how much it is and where these are to be able to design policies and strategies to bring this water back to the water budget. Okay, so this is one of the tools that we have developed for water reuse planning and assessment, right? Next slide, please. In Lebanon, we adopted a different approach. In Lebanon, and this also is published, and I can share it in the chat. In Lebanon, we geolocalized the existing and planned wastewater treatment plants in the country, which are the red dots you see on the map. We also had the existing and planned irrigation schemes in the country, right? So the objective was to understand water reuse potential for agriculture in Lebanon, right? So what we did was to design some command areas, these perimeters, these red perimeters you see around wastewater treatment plants, which were the areas at an economic distance from the wastewater treatment plant. Distances beyond which is not economic to transport this wastewater. So the intersection between these command areas and the irrigation schemes give us the areas where there is potential to reuse. And then we had a scoring system based on the presence of or absence of canals to transport this treated wastewater based on the good match between the available between the quantity and quality of wastewater that was generated by treatment plants and the quantity and quality of the water that is required by crops, whether when there was a good match, we gave a higher score, and when there was a poor match, we gave a poor score. And then we had a scoring system that helped us understand in what treatment plants there was better potential for reuse. And this helped us also to prioritize or provide advice to prioritize investments, right, in Lebanon. These type of technologies And this type of approaches, the previous one and this one, are mature already. We have experiences that shown that they work and that they produce reliable results and can be replicated in other countries as our programs grow. Now, next slide, please. And this is my last one. We are now currently working with Google with 2 projects to improve these approaches by using artificial intelligence and satellite information for the automatic identification and characterization of wastewater treatment plants. And that's critical because in many developing countries, data on wastewater treatment plants is either not available or more frequently is not accessible. It's not in the public domain. So if we have models that allows us to identify automatically where they are and what are their basic characteristics, we will have very, very useful information for water reuse planning, but also for SDGs monitoring. We can have almost real-time data on how the wastewater treatment sector evolves, right? So I don't have much time, but the 3 first steps you see in these graphs, the red, the orange, and the yellow, basically are for the automatic identification of wastewater treatment plants. We are training an artificial intelligence models with a lot of images of wastewater treatment plants and images that look like wastewater treatment plants but are not, like drinking water treatment plants, refineries, another type of infrastructure that could be confounding factors. And we are getting a model that is able to predict to a degree the presence of wastewater treatment plants. In the first run, we are having a good number of false positives, and we are now working in retraining the model with these results. And in the future, in the coming future, we are going to work in the automatic characterization of these wastewater treatment plants. And we are working on identifying what features that could be easily detected from satellite imagery, what features from these wastewater treatment plants could be good predictors of the capacity. We are testing, for instance, the number of circular features that could be the primary or secondary clarifiers, or the total surface of the treatment plant, this type of features, so that we can build a multivariable correlation model that allows us to predict the capacity of these wastewater treatment plants that we are automatically detecting. So this is an emerging solution. This is a model that, if we get it right, could have major potential, not only for water reuse planning, but also for example, monitoring of SDGs, right? So global applications, regional applications, national applications. So stay tuned as we progress with this project. We will be releasing results as they come. And I will be happy to keep you informed on this. So with this, I wanted to conclude. Next slide. Thank you very much for the time and for the invitation.
Thank you, Javier. Thanks so much. Thank you so much, Javier. We really appreciate you joining us online and look forward to bringing you back in for our Q&A. I'm now very pleased to turn to Anne, who is a member of the ExCom of Veolia. And as we've been talking quite a bit about both physical infrastructure and digital infrastructure, I think that this next presentation will do a great job in knitting together these themes as we're thinking about what Javier was speaking to of if we get this right. And here will be a great series of examples of the combination of technology, infrastructure, and innovative business applications for global resilience for water. Anne serves as the Executive Vice President in charge of global technology sales. She served with Veolia since 1998 and held a variety of roles related to technology, waste management, and recycling. And over to you. Thank you.
Thank you, Rebecca, and thank you, Ida and Javier, for addressing all the potential that is ours. As you mentioned it, Rebecca, actually a bit more than 20 years ago, I was a young engineer operating a wastewater treatment plant at Veolia in France. And that was quite an advanced one because I remember that during the official visits, we used to demonstrate the performance of the plant by offering to the visitors to test the water at the outlet of the wastewater treatment plant. That was Winduck, before Winduck, because the water was already compliant with the drinking water regulation. But you know, that was kind of bold to do that, and everybody was like testing it. Am I obliged to do so? Is it because it's polite? But honestly, it took a very, very long time for us to really achieve and convince that water can be drinkable at the outlet of the wastewater treatment plant. Today you demonstrated it, Heather and Javier. Water is definitely too scarce to be used only once. And apart from Windhoek, that is an example that I love, that popped out years ago already. Honestly, today we have very few examples of that kind. We talk about acceptance sometimes. We at Veolia, we conduct every 2 years a barometer of the ecological transformation. We interview thousands of people all around the world in every country, so we have a relevant sample of people expressing themselves about climate change. This year, one of the main outcomes of this interview was that 2/3 of the population worldwide is ready to accept to even drink the reused water if water is too scarce and if they don't have water anymore. So acceptance is behind. Let's talk about technologies then. Let's talk about technologies. Well, there is a high demand, we've talked about it, not only for municipal drinkable, we talked about irrigation. Of course, irrigation is a big topic. Let's talk about industries. Industries consume half of the overall water consumption in the world. And the pace is growing. The pace is still very fast. So if we want to support the human progress, we need to support the development of the industry, and the industry needs water. So water is there. Water is never at the right place, never of the right quality, but we know how to do it. Providing even ultra-pure water for industries like pharma or microwave that are booming today, it's absolutely necessary. Of course, we have more biological treatment needs. Let's talk about food and bev, for example, that will have more biological kind of needs. And we now talk about micropollutants. We are all scared about health, and after the pandemics, everybody is more concerned than ever. So we also have now new pollutants coming in the game. Wherever there's no water, desalination can be a good solution. This is all the kind of demand that we have today. What does it mean? It also means that we are consuming energy, because all our water processes are encompassed in the nexus of energy and waste. I won't be very long on that one, but wherever you remove the pollutants from water, you have waste, you have sludge, you have pollutants. So let's keep in mind this nexus, and I will come back on this a little bit more later. Reuse, as I said, is a very well-known process, and we know how to treat any kind of water up to a level where it can be compliant with the regulation for drinking water, or even for ultra-pure water for the industry. Let's take a very more standard example in Barcelona, where the wastewater treatment plant treats the equivalent of 1.7 million inhabitants, and the usage that we're doing there are multiple. First, whenever there's no water anymore, it can go back to the river. So we make sure that the river is always fed, and that we fight against the aquifer salination, because if there's no water, the sea is coming in. Whenever there's no need for the river, we can irrigate, and the agricultural is very, very important in that region. So irrigation is a must. Wetlands enhancement is possible, but we can also provide water for streets cleaning, which is okay, which is good. Well, maybe soon they will also go, as we do in Namibia, and make sure that wherever they need water for drinking water, they go up to that extent. How do we do that? Well, technologies are very mature to do so. Of course, we remove the suspended solids, phosphorus, and dissolved organics, and we have a series of technologies at Veolia, because we develop and manufacture our own technology. We have manufacturing plants, but we also have labs. We have 10 labs all around the world and more than 4,400 patents that we are still improving and redeveloping to make sure that we're adapting to the new conditions that I mentioned earlier. ActiveFlow is one quite well-known technology that we're using on that, disk filtration. Then, of course, we go for disinfection with UV or chlorination. But I think that the most interesting in this process is definitely the membranes. From ultrafiltration to nanofiltration up to reverse osmosis, membranes today are definitely the very best way of removing any kind of particles and pollutants in the wastewater or in the water if you want to have ultra-pure water. Membranes are just amazing, you know, and as I said, you can use them for municipal treatment, but I want to focus today a little bit more on industry for a change, and because this is also, as I said, a very important consumption from our customers. Few examples, Nestlé. In Mexico or even in China, well, they realized that 87% of the milk is made of water. And when their job is to transform the milk into powder, they have water remaining and they were discharging this water. So thanks to our technologies, they decided to recycle this water for their internal needs, and they're not discharging anything anymore. So we are recycling this water so they can consume it, all the water in excess, or sell it to the neighborhood. Another example would be car manufacturing, same process, no discharge. That's the example of a Renault plant in Morocco. No discharge, and all the water is recycled for their internal processes. But something maybe a bit out of the boundaries for today is that because membranes remove all the particles and pollutants, of course we can filter the water, but we can also recover the raw materials, salts, critical metals, and precious ones. So when you think about the energy transition, when you think about the cycle for batteries that we're using more and more, of course, there is a need now for more critical metals, more raw materials like lithium. And well, we're already one step ahead in terms of circular economy, looking at how we can, while reusing the water and treating it to an extent where there's nothing more into it, recovering the lithium, for example, from the brine in desalination or for the concentrate for the industrial water. This is a map of where direct lithium extraction is done, so we can support the mining industry in reusing the water. That's a heavy industry consuming a lot of water. They need to decrease the consumption of water that they have for their operation, so we recycle the water for them, but on top of that, we can recover the lithium from it, so they have a kind of cherry on the pipe and recover more lithium than they extract from the direct mining. Of course, if it works for mining, it will work for battery recycling. So let's look ahead, think about innovation, circular economy as a whole, and let's scale up, speed up when it comes to reuse. Thank you.
Thank you. And may I invite you to stay on the stage because we're going to shift into our Q&A. If I may call all of our speakers up to the stage, and perhaps we will pull up Javier. Thank you. Maybe I'll have you stand here with the mic if that's right, Anne. Thank you, thank you. All right, many thanks to Anne, to Berenice, to Heather, and we're being rejoined by Stephanie, who will help moderate our online Q&A. As we shift to our Q&A, we're going to start with a question to each speaker before we open it up to the room and to our online participants. So please be thinking about what you would like to ask our remarkable panelists today. I'm going to start with a question to Berenice. As you were talking, I was wondering what some of the bottlenecks have been to direct potable reuse and recycling, and how you've overcome some of those difficulties.
Okay. Thank you, Rebecca, for that question. I think initially when we started going the reuse route, it was one of the early adapters, or the first adapter for reuse. So we didn't have the regulatory framework to actually transition into reuse. So we had to first test the technology, ensure that it was safe to use, especially because you have people's lives in your hands. So we needed to test the technology, ensure that it was safe to use, and then also to build the policy, the regulations, as well as the laws around reuse. So after that was done, we needed to ensure public perception issues around wastewater reuse for direct potable purposes. So that was the stepping stones that we had to go through in Windhoek, which took quite a long time to actually build the public perception towards the health and safety aspects of the water for the consumers in Windhoek, and then also to build the regulation framework, as well as the policies that actually allow us to reliably and sustainably do DPR in Windhoek. So those were the two bottlenecks, and we worked with the government as well as the local authorities and a private sector company, Veolia, in order to ensure that the regulatory framework and the regulation was done efficiently. Yes, and currently what we do in Windhoek, we're one of the pioneers for bioassay monitoring for health in Africa. So moving towards normal chemical analysis as well as biological analysis, we have since 2018 been doing bioassay monitoring on our water, just to ensure and to also provide transparency to the people that our drinking water is safe and reliable.
Thank you, Berenice. Well, certainly many lessons to be learned from the Namibia case for other arid countries or countries that are new to developing this kind of technology and regulatory framework. I'd now like to turn to Heather. If you might be able to speak a bit to urban stormwater as a water reuse strategy for augmenting and sort of diversifying water supplies, especially in arid regions.
Great, thank you, Rebecca, for that question. I do think of, as I talked about at length, stormwater as really being a key component, part of a circular economy for water. I think there's been a lot of emphasis focused on wastewater, industrial wastewater, or municipal wastewater. I think those are key pieces. Stormwater has been historically not part of that, and I think there's a real opportunity to bring it into that same framework. I think, as I noted, it represents wasted water. We think of wastewater. I think of it as wasted water, and I put stormwater capture in that bucket as well. In our urban areas, and we're seeing this, frankly, around the world, this concept of sponge cities, right, where cities from Germany, Asia, even in the U.S., Philadelphia, and many others are sort of adopting this type of sponge city approach, thinking not only about drought but also floods. As we see the intensifying effects of climate change, we're seeing more extremes. And so there is a real need to rethink how we use and manage water, rethink stormwater such that we are capturing it, storing it for later use, and reducing that flood risk, the water quality. We're even seeing in many areas thinking about greening cities, increasing biodiversity. So there are many, many co-benefits of stormwater. And so again, just an important strategy for not only sustainability, but resilience for our communities.
Thank you, Heather. I think that's a timely application, certainly in the US, where we're seeing a lot of urban flooding happening, particularly in coastal cities that are increasingly vulnerable to the effects of climate change. I'd now like to turn to Javier online. It would be great to hear from you, given your experience in a number of geographies working with IMI, what some strategies might be for translating research into practical, scalable solutions, both for communities and industries, including agriculture, within this framework of a circular economy.
So thank you very much for the question. Basically, and that's a critical question, actually, because we don't want to be making research for the sake of publishing only, right? So there should be science policy dialogue, a constant science policy dialogue facilitated by knowledge brokers, people that understand the two words. And this is also something that IMI does. We understand the importance of transitioning or translating research into reality change. And we have worked very hard in our projects to include participatory approaches, to include stakeholder engagement. In a project, for example, that we had called Rewater MENA, we use learning alliances where we had the academia together with policymakers so that we could discuss what policymakers need and how we could help, right? So these type of approaches are essential to translating research into reality change and policy change. Thank you.
Thank you, Javier. As we're thinking about this role of policy and research applications in facilitating this sustainable, just transition and the uptake of these types of technologies and innovative solutions, I'd like to turn to Anne and ask, do you anticipate major technology jumps in the decade ahead? And is technology a driver of change in water management, or what is the role of policy in facilitating that?
Yes, indeed. Well, we innovate every day. R&D is absolutely key in technologies, being water technologies or this. But I think the major shift is related to what Javier presented. I mean, it's digital and AI that will definitely transform the way we look at things, the knowledge that we have, and our ability to react. So definitely digital AI will be a game changer in the years to come. And technology will continue to evolve, to be more efficient, and to make sure that we enable the treatment of new pollutants and are able to preserve the resources and the health of the citizens. You mentioned policies and governance. Definitely, we are providing technologies. We are water experts. We are not the one deciding. So the governance need to be fed by data, by facts, and by knowledge about what we can achieve. But they need to make sure that they make decisions and that they build policies. So again, we can scale up.
Thank you, Anne. I'd now like to transition to you all and hear from all of you to engage our panelists on some of these themes that we've brought up here today. And I believe that we have some SIWI colleagues with microphones, if we may open it up to the room. Please, over to Tony. Thank you.
So this is for Berenice. Curious how the projects were financed and, capital, and then do tariffs support the ongoing kind of what's next and what keeps other countries from doing this? First of all, fantastic what you've done. You're really at the forefront. So congratulations to you and your country for doing that.
Thank you so much for the question. So the first plant in 1968 was funded directly by the government. In 2002, the new Gorenga reclamation plant was funded by KfW, as well as the city of Windhoek. So that was a project where the O&M contract went to Veolia as a PPP, a public-private partnership. And then the infrastructure was then given to the city of, well, not given to the city of Windhoek, but they basically applied for a KfW loan, which financed the construction of the plant. And then the O&M went to Veolia. And then that is directly funded through tariff systems. So they bill the city of Windhoek for the water that's produced. Yes, so then the Uyams project is also a PPP, and that was funded both by Veolia itself as well as other private partners, and that is a BOT project. So the transfer will be done after a period of 21 years. And then the managed aquifer recharge is directly funded by the national government. So you can see that the financing schemes for the different plants are quite different, where you have one being financed by development bank, then private equity, and then national financing. And then your second question was, what is keeping other countries from doing it? I really have no idea. I feel like everybody should be doing it, because ideally we would like to close the water loop and try to recover as much internal resources as possible. But I would maybe suggest financing, because in Windhoek, the beginning of DPR was done such a long time ago that the wastewater treatment track, or should I call it a track, but it was not well developed. So we had the opportunity to really develop, keeping in mind reuse at the forefront, which is not common in a lot of other cities. So reuse is more at the back end, where we had reuse at the front end and sustainability at the front end, which is quite different. So we are at an advantage where we could really map our development such that we are more sustainable, which is not the case with a lot of cities. But I think that many other cities have been trying to find feasible avenues for reuse, and I think that it'll be gaining more traction in the near future. Yeah.
Thank you, Berenice. And going forward, we'll be repeating audience questions to ensure that our online participants can hear. And over to you. Thank you.
Thank you so much for the presentations. Coming from Athens, Greece, where I try to exercise through the water utility of Athens plans for reuse, both wastewater reuse and stormwater reuse, I find that the major difficulty is actually the resilience of these master plans in terms of the cost of the O&M. So following that question, you spoke about tariffs, but I'm opening this question. What kind of regulatory changes or what kind of incentives can there be in order for these things to be more resilient? Because they're expensive sports, you know, both wastewater reuse and stormwater reuse.
Thank you.
Stormwater reuse in Greece is very expensive because it doesn't rain.
Right.
That's another issue with stormwater reuse. So just opening the question about an O&M and the cost of water. Thank you.
Thank you. So to repeat the question, for both wastewater and stormwater reuse, what we're noticing is that the resilience of master plans for operation and maintenance costs is perhaps not where it could be. And so the question is, what kind of regulatory incentives or changes might be necessary for areas that need some development in this theme? Maybe to Heather and to Anne?
Yeah, I can speak to that, and to the cost question, I think, is another big component. As was mentioned, when you all started in this, there wasn't really a regulatory scheme, and so that was part of the process in terms of allowing it to go forward. And I will speak from a U.S. perspective. What I've seen in recent years, similarly, there really wasn't many regulations as it related to direct reuse. Now, just recently, though, we've seen several states step forward and establish regulatory frameworks. The first being Colorado, which is sort of an inland state, but is dependent on the Colorado River, which is a severely constrained supply and becoming increasingly so. The second state being California. California just passed a DPR regulation. Interestingly, it was really driven by legislation advanced by an environmental group, that was seeking to protect coastal resources. They're seeing lots of discharge into coastal waterways, and so this was of interest to them to protect the quality. So that was really what drove the state regulator to pursue that and to set up standards for treatment, to set up monitoring standards as well. And so I think that's really points to an opportunity for some interesting alliances in terms of moving forward some of these regulations. Now, as we get more and more places with these, it becomes sort of easier then for the next state, the next country to adopt regulations that establish not only the requirements, but some of the performance requirements associated with them. To the cost question, though, a really important one, DPR is expensive. Now, again, costs will vary depending on lots of local factors. But what we're seeing in many areas, some of the costs coming in are high. They're less expensive than desalination, but often more expensive than efficiency or some of the other supplies. So I think we'll see more and more projects, as was mentioned, over time. But really what's available in any particular community is going to vary. And it can vary pretty dramatically, not only what's available, but the cost. And so part of it is understanding what the potential is, as Javier spoke to, can be really important in terms of opening that conversation up to then start to prioritize some of those that can be done at lowest cost and with some multiple benefits as well.
Thank you, Heather. Javier or Anne, anything you'd like to add?
Yes, I may. With regard to this question of the cost of operational maintenance and what to do about it, right? So the first and obvious answer is to lower the cost of operational maintenance. So we should try to avoid repeating the mistakes of the past where we keep investing in wastewater treatment plants that have very high energy demand and energy costs and high operational maintenance costs. There are emerging technologies that are addressing the issue, and it's true that engineers and policymakers tend to keep investing in things that they knew they worked, but energy is scarce, operational maintenance costs need to be recovered, and there are solutions to try to lower those. And then, of course, there will be always operational maintenance cost, no matter what. So it's a matter of recovering part of this cost, designing the business models that can ensure that there is cost recovery. Because water reuse has environmental benefits, and therefore the whole society benefits, there is, to a degree, a justification for subsidies, right? But then also we need to consider the polluter pays principle, right? The cost of the wastewater treatment up to the level where it should be good to be discharged into the environment should be paid by the polluters through tariffs. I mean, this makes total sense. Also, although in developing countries, increasing tariffs, it's hard, and then there should be assessments and ways to compensate the poor if this happens. And then with the rest of the additional treatment, if there is a need to treat wastewater additionally to the quality that you would have for discharge, then we need to assess who is going to benefit from this water and what are their capacities to pay to be able to design a fair but effective cost recovery mechanisms that ensure the operation and maintenance of these wastewater treatment plants, which is a critical point, right? So these were my 5 cents on this last question. I could also react on the other one on Berenice if time allows.
Perhaps we can come back to that, but I think maybe we'll turn to our online participants before we turn back to the room.
Okay, so we have a few questions online. So the first question is by Niyati, who has been asking, how did you change the mindsets of citizens to be able to use recycled water to drink? And how can this be done in low-income countries such as India, Bangladesh, and Nepal? So surrounding countries where this could be a taboo issue for them.
Thank you for the question. So initially, the political framework in which the first plant was designed and built was during apartheid. So there wasn't a lot of interaction with the population in terms of the decision-making to build the plant. But after independence, one of the key pillars was to actually engage the public and to sway public perception and transparency. So we have a lot of tours and we have a lot of public engagement as we do here in this room. We do the same thing in Namibia and elsewhere in the world where we present the data. We present the results. We have people come to the plant to see the process, to see with their own eyes the transformation of the water and its quality. So we try to back up our public engagement with scientific facts to really give confidence to people that the water is safe to drink. And we do this as an ongoing basis since its initial inception until now. So I think that's one of the factors that we do use to sway public perception, is to really give confidence to people to see for themselves and also to we prove it that the water is safe for drinking. So I think that's very important.
Thank you.
Can I add one thing on that? So I think those are all, I think, really important strategies. I see them being done in lots of different places. Another sort of interesting one I've seen is there are a number of breweries, for example, that are making beer with recycled water, wine, and so there's just been, and they're very public about it. It's just part of, we're being, good stewards, and we're responding to the drought and creating this. And so this is another sort of tool or strategy. Obviously, there needs to be, cultural sensitivity and recognition of that. It'll vary depending on how to do that, but it's just another tool that has been effective, again, not for a subset of people. So I think there's a lot within water to improve around communication and transparency and really educating people about kind of all of the strategies, not only the strategies and solutions, but the pressures. I think as people understand the scope and scale of water challenges, they can very quickly shift their understanding and perceptions about some of these strategies and the solutions.
So the next question is to Heather. How do you see the potential? What are the pros and cons for having a spun city approach in the US?
Yeah. Great question. Well, I touched on some of the pros, but I'll reiterate. I think in terms of looking at both floods and droughts, as communities are experiencing this, even communities, frankly, that haven't in the past, right? With the changing climate, we are seeing more extremes everywhere. Even areas that haven't been prone to drought are becoming so. There are the greening benefits, of course, water quality benefits, all sorts, even community cooling in areas where there is a lot of concrete. We have urban heat island impacts. And so putting in some of this green infrastructure can be very helpful in terms of mitigating that, reducing then household energy use and greenhouse gas emissions, improving public health. So there are a long sort of list of co-benefits there. I think some of the challenges in doing this are it's really a big shift for urban areas. They have to rethink in terms of their whole design of their sewer systems, for example. Now there are, and create space for that green infrastructure. And so there can be significant construction associated with that, cost associated with it. But as there's new development, as there are areas of redevelopment, then that's a way of trying to help contain some of those costs.
Thank you so much. Another question that has come in from Ashish is that how can technical solutions be adapted or scaled in low-income regions where infrastructure and regulatory frameworks are limited? Could you share any successful examples you have encountered in such context?
I think the very first step is really to look at what we have and all the needs and alternatives. I presented a few quick steps on reuse, but of course we need to start with the beginning, and wherever nature-based solution can fit, well, they perfectly fit. And then we go one step ahead and really adapt the technologies to the need and not the other way around. So the very first thing is really to look at what we have in terms of water, in terms of resources, in terms of needs. And I think in that case, Windhoek is again a good example, because when they started with it, they had this ability to split the domestic and the industrial networks. So we need to be quite creative when we look at a project, and depending on the geographies, the context, the need, we need to make sure that we look at I was about to say district manager areas, but segregated areas, because not everyone has the same needs. You will not do the same thing for pure domestic or very industrial, a mix of both. So you need to be quite creative in the way you look at a project, and make sure that, you don't put a Rolls Royce where you need a deux chevaux. That's for French people.
Thank you.
Thank you so much. Are there any questions?
Thank you very much for all of your great presentations and very inspiring as well. Another question on technology to you, Anne. You mentioned desalination and superior membrane technology as well. We're talking also about sustainability and circularity. What's your view then on brine? Is that a regulatory thing, or how do you see that developing and in your experience?
Yeah, thank you for that question. I'm quite passionate about desalination, because I think that there has been a past and there's a future for desalination. Years ago, in the Middle East mainly, we were doing thermal desalination, and everybody keeps in mind the energy consumption of that kind of technologies. Of course, it was consuming a lot, but just coming back on the previous question, in the Middle East, they had no other solution. So yes, that was costly, that was consuming a lot of energy, and they've developed quite a lot of power plants to fuel the desalination plant. Today, we've shifted completely on desalination, thanks to the membranes. With reverse osmosis, we have decreased by 5 the consumption of energy of the desalination plant. So the energy consumption of that type of technology has decreased dramatically. So now desalination is more sustainable and it's more affordable too, because actually the cost of energy was half of the tariff, more or less. Coming to the brine, there are some bias on brine because people think that the brine was rejected anywhere, anyhow. That was absolutely not the case. Even more than 30 years ago, a lot of studies were to be done before any discharge of brine in the sea to make sure that the dilution would be okay and that we were discharging as less as possible. So there are a lot of bias on brine. Again, today, the technologies allow us to really concentrate brine, remove whatever can be reused. And that was my point in the presentation. If you take a desalination brine and you really invent the business model that goes along with it, you take out the salts, you recover the salts, and you make a business model from it, then you can feed a country with magnesium, with phosphorus, with boron, and more. So brine is salt. It's concentrated, but it's salt. So my point is really to say we have the technology to recover the salts and to reuse them because those are produced one way or the other by other industries. So we can push the boundaries of circular economy in that field. And then the discharge will be less and less. But again, the discharge of brine in the sea is something that is perfectly studied and perfectly safe.
Merci beaucoup.
Merci.
Can I make one comment on
Please, Heather.
on that? I just wanted to make one comment on that. I get a ton of questions. Why not seawater desalination? That's probably the most common question I get. I think one of the things we need to move towards is to think comprehensively and holistically about what the options are in any given location, and really make decisions based upon a variety of factors, cost being a really key component, but also thinking about what are the costs and benefits, the other things that may not be financial, but may have other sort of qualitative or quantitative impacts, environmental impacts, for example. There's sometimes sort of passion about a particular technology, and I think there are risks in doing that. There are risks in putting in more expensive things before you've done the cheaper things. We've seen that in communities around the world. And so I think we just need to take a balanced and holistic look at the various opportunities there are in any area and be really thoughtful in terms of how we move towards them, and looking not only at the water supply options, but also some of our demand management options that we have available in communities. And again, the relative number of those, the relative costs, those are all going to vary from community to community. But when we take that comprehensive look, we'll end up with a better decision for our communities.
Thank you, Heather. Please.
Hello, everyone. Thank you for an amazing session and letting us know how much potential we have in water use. I want to know about how smaller can we get with the scale of the infrastructure that is required. So this happens a lot of time that people from government and people who have funding, they want to see some sort of success in whatever method we are using. So like how smaller can we get, and would that be financially viable to create a smaller plant and then upscale it with the passage of time?
Thank you. Shall we start with Javier?
Okay. Well, of course, there is an issue of economics of scale, right? So the larger the treatment plant, typically the lower the unitary costs for wastewater treatment. So there are typically concerns about investments in too small wastewater treatment plants. But of course, if we are talking about innovation, new approaches, we need to start small and then scale up. Start with pilots, see how they work, and see how to replicate and scale up. Considering that by doing so, you will reduce the unitary cost. So it makes sense to start small if it's a new thing that you want to test. That's my answer right now.
Thank you. Heather?
Yeah, it also, as we see greater variability too in not only supply but demand, I think there's also this opportunity for us to think about modular types of approaches. I mean, yes, with larger plants, there's economies of scale, but there's also greater risk there. If you have a reduction in demand, for example, then the unit costs actually go way up if you don't need as much from that facility. And so thinking about modular approaches then enable us to be flexible depending on how things play out. I mean, we often have projections of population growth that may or may not actually come to fruition. Lots of factors, I think, go into that. So I'm seeing increasing interest in this more modular type of approach that allow for flexibility and greater resilience more broadly. And so I think there's a lot of innovation possible in that space.
Thank you.
Are there any more questions in the audience?
Please. We have time for about one or two more questions.
Okay, thanks for a great session. A quick comment and then my question. My comment is about the question raised earlier about changing mindsets. And one example came to my mind is what Singapore did, which was outstanding, in terms of realizing that is a future generation which is going to have to consume that recycled wastewater. As a result of which, they got each and every child in Singapore to spend a full day at the wastewater treatment plants to see for themselves the what and the why and taste the recycled water. I thought that was a great example. My question is to you, Heather. You talked about some of the challenges in terms of realizing the true potential of storm water runoffs. Is there any example of a geography which has done a good job, which people can learn from?
Yeah, great question. So I think there are lots of opportunities and lessons from around the world. I think obviously Windy Hook is a fantastic example that I point to all the time in terms of DPR. One of the places where I'm seeing, and stormwater capture as well, I mentioned some of the sponge cities that are out there that have some really aggressive goals around capturing stormwater. One of the areas I've been looking at too in California, which is where I'm from, is Los Angeles. They have been a large city, a large metropolitan area, about 20 million people, and really dependent. They're in a very arid climate and dependent on imported water from outside of the state, but also from Northern California. And they've set some pretty ambitious goals around becoming less dependent on those imported water because those supplies are becoming less reliable. One of the things that they did, interestingly, was they passed a property tax such that generates about $300 million every year that they're using to invest in sort of stormwater capture projects from a water supply, but also a water quality sort of benefit and a green infrastructure benefit as well. So that's been a really interesting program. It's still passed a number of years ago. I think they're still ramping up. A lot of lessons learned, both good and bad. But it's a really interesting example where the community was really willing to tax itself locally to sort of start to pay for that. And I think that's a model I'm seeing other communities in the US start to look at.
Thank you, Heather. Would any other panelists like to comment on that? If not, I think we have time for one more question. I believe we have one more in the audience. Thank you.
Thank you. Ian Bale, work with a water utility in southeastern Australia, and we're also challenged by water scarcity, and thanks to all the panelists for great presentations this morning. Quick comment and then a question for Heather. You seem to be catching a bunch of the questions. In our largest community, about 40,000 people, we've looked at stormwater and figured that we don't have to accept all stormwater. We can segregate the stormwater. So the new housing developments in the area all have two stormwater pipes coming off them, one which goes into our city water supply and the other which goes sort of the traditional stormwater path. To get to that point, we had to deal with a lot of cross-jurisdictional questions, developers, homeowners, planning regulations, health departments and so on. And ultimately we got there, but I'm interested in your reflections from the US. Are you seeing the emergence of this, I guess, coalition of the willing, that multi-agencies wanting to actually have the conversation? And if that's occurring, what might be some of the learnings from that can be promoted elsewhere? And if it's not occurring, what are some of your thoughts on how you get those cross-jurisdictional conversations going?
Yeah, great question. And I think that is one of the biggest challenges with stormwater in particular, because in the U.S. and in many areas, but especially in the U.S., there's a huge amount of fragmentation. So it's one agency that's doing water supply, another one doing wastewater, and then a third doing sort of flood risk, stormwater management. And often they're not geographically the same, right? So you have lots of different, I think, challenges. And so trying to get these organizations, these institutions to start to work together, there are constraints on even them being able to share money with one another. That's a huge issue. Where we've seen some progress are formations of these joint powers authority. They sort of come together and create sort of a separate entity that can support and fund projects. We also see sometimes at the county level, which is tends to be bigger than the city, and that's a place where these different institutions can sort of come together. But it is one of, I think, the biggest sorts of challenges in dealing with that. And part of it is just trust building and relationship building between the agencies. I will say, here too, we're seeing some of the environmental groups become really active and try to sort of broker some of those relationships and to pass things like the property tax and other types of things. So, I sort of alluded to this or mentioned this explicitly, bringing in sort of different groups to support these types of projects can be really influential and effective in moving them forward.
Thank you. Thank you so much, everyone, for your great questions, both in person and online. We're now going to transition to our closing statements from our panelists, and we'll begin with Berenice.
Thank you all so much for your time and your inquisitive questions. I think one takeaway that I would appreciate everybody in this room to leave with, it's just to rather think of resources differently, that as Anne has said, each and every single waste stream has a recoverable entity to it. And I think that component is quite key to a sustainable future. So it might be water, it might be fecal sludge, it might be metal components within that wastewater stream. But I think it's just important to take away that wastewater isn't just wastewater, it's used water and can be reused. Thank you so much.
Thank you, Berenice. Heather.
That was a great point, Bernice. I think I would walk away, or want everyone to walk away, to realize we talk a lot about the challenges with water, but there are solutions, and I think there are ways and for us to sort of work together to advance them collectively. And so I think I have a lot of sort of optimism for water. I just think because of all the waste we have had historically, we can really move forward on a different sort of path. It's not only an opportunity, it's going to be a necessity. And so I'm really excited about the sort of opportunities for innovation as we move forward.
Thank you. I hope we can all capture some of that optimism. Javier.
So thank you. So, well, I think that in the view of climate change and increasing water scarcity, we need to bring new water back to the water budget. So we need more reuse, right? We need to assess water reuse potentials and plan for reuse to prioritize investments. That's also very clear. We don't want to invest in solutions that do not have economic sense, right? And we have seen that we have digital solutions based on remote sensing, GIS, data science, artificial intelligence that are key for planning. Some of these are matured and can be replicated, and some others, like those related to artificial intelligence, so we really need to keep investing in those.
Thank you. Thank you so much, Javier. Anne, please.
Thank you. Yes, indeed, the need is there. And, most of our research and development at Veolia is focused on performance. And when I say performance, it's not necessarily doing more. It's also consuming less, saving resources, being energy neutral, and reducing the amount of waste. So we can make all our technology more affordable, more sustainable, and we can make sure that the technologies come and give confidence to the governments, to the authority, so they can really decide. Because, again, now we need to scale up.
Thank you, Anne. Thank you all. The themes I think that have emerged both from your presentations and from your engagement include the intersection of physical and digital infrastructure, including the convergence of how these relate to technology, and understanding that we don't have just one solution, but that as we can be more comprehensive in our outlook, we can think about different types of solutions, including those that might be modular or decentralized. We've talked about the role of research and good data, including in how that might inform good policy, regulation, and governance, and co-producing business models as technology advances and becomes more acceptable. We also discussed public trust and how to drive demand for solutions through these coalitions of the willing, including some that might be surprising or unexpected across a range of contexts. There's other areas certainly ripe for more exploration, including the role of education and how all of these become more than the sum of their parts. I'm going to click ahead here so we can go to our slide that has the information about our next session in this series. If someone might be able to assist with getting to that slide. I would like to close by thanking SIWI and the Stockholm World Water Week for providing a venue for this important and timely discussion. Certainly, Water for a Peaceful and Sustainable Future will be closely related to everything that we've discussed here today. I'd also really like to thank Veolia, including Dominique and Anne, for their expertise and their pulling together the session, to Winrock and Berenice for bringing the example of Namibia and Windhoek here, to the Pacific Institute for their intellectual leadership in this area, to Heather, thank you for your expert commentary and the research, and to IMI, to Javier, thank you for dialing in online and for the excellent work of IMI contributing to this field. And Stephanie, thank you for everything you've done to keep us organized and on time this day. And of course, to our audience, both in person and online, for your excellent questions and engagement, which I hope will continue on for our next session in the series. We're working on getting that landing slide up, but in the meantime, please join me in giving a round of applause to our panelists.
So we will put up this slide. So until it is coming up, so the next session would be tomorrow, the 28th of August from 11 to 12:30 in room number 27 at level 2. So that will be covering the Wi-Fi nexus for transboundary contexts, and it will be a continuation on our series session. So look forward to seeing all of you over there. Thank you.
Thank you.
So the sessions is out.